Hi everyone, it has been some time, so welcome back. Today we're going to talk about matchlines. For those who don't really use matchlines, matchline is used in dependent views to show the boundary of one of the views versus the other views. So like here it's indicating that there's two primary view and that dark dash line is the match line, and then the shaded dash line is the view crop region. So as you can see from here that you usually crop your view a little bit beyond the match line, where you're indicating that everything on the left of this match line should be in this view, everything on the right should be on the other view or the other sheet. But then because your crop region is like be further away from the match line, sometimes there are gonna be things just in just outside the match line, but also shows up in this view. And this is where you get like duplicate informations because whatever goes in here goes into both sheet and both views, and sometimes it's just annoying. So today we're going to talk about how to deal with those. And here I have a simple project with some typical families. These are the chairs, desk light, and some ceiling light. All the things that I've used in the past. And we have a building just like that. The pink line, the magenta line shows the match line, and the green lines are the different scope boxes. So you see that there are match line indicating the boundary of the informations, and then each of these scope box a little bit beyond the match line or beyond the wall, the exterior wall that is. So you end up with something like this, and then you end up with there's 18 scope box and 2 floors, in which case I have placed these families. These are the ceiling plans, you see the light. These are the floor plans, you see the chairs and the lamp, the desk lamp. And in each of these views, there are things beyond the match line. So in a typical project with this many scope box and views, you easily encounter, like right now I have 72 views, 72 individual views, that's 18 times 4. And all of those views have things like just beyond the match lines, and they're just showing up in this view and in the other view too, which is just annoying to some extent. For example, if I go here, it says scope box 2 and select all these and open the sheet, it says scope box 3, you see that they are here as well. So if you don't know that, you would like double quantify them because they show up in both of your sheet. And today we're going to talk about how to use Dynamo to batch visibility graphic override these. So basically, this is how it's going to work. We're going to just show how it runs. I'm going to go ahead and select all these sheet that contains dependent views and match lines and things beyond match lines potentially. And I'm going to run this matchline override multiple. I'm going to start by timing this. Okay, come back here, select that, and run. So what this script does is going to loop through all these sheet, find the views on the sheet, and then find all the element, find the match line on the sheet, find all the element on this sheet, on this view, and filter out those that are sitting beyond the match line and gives them a visibility graphic override. Basically, turn it into some light color dashed lines, halftone, so that they kind of fade out from this view, and make sure that you're always focusing on what is the main content of each and every view. While we wait for this to run, it should take a little bit more than 3 minutes. Let's talk about the other options for this thing. Well, typically you could just go there and click and manually hide all these elements that are beyond the match line. Well, that's the tedious part, and that's like time consuming. The other way, however, is to like create a mask region just beyond this boundary, and technically you can copy paste that between different views. For example, the level 1 floor plan, the level 1 ceiling plan, the level 2 floor plan, level 2 ceiling plan in our example, and you can just copy paste those field regions across the views, so it's a little bit faster. But if you think about that, the field region won't cover any of your say device tags, annotations, room tags, etc., etc. So there's that as a problem. The more advanced option would be like to create a field region over here on this sheet space. Imagine you just place a field region over here to hide everything. That was an option back in Revit 2017, where it's still like you can trick it to place a field region on sheet. But in 2018, that is no longer an option. Which leaves the like the only option you can create a annotation symbol that contains a field region and place it on sheet. It will cover both the model element and the annotations that are resides beyond the match lines. Okay, we're already finished. But then like right now, if you imagine I could just come here and place a annotation, and that's like, for example, that's opaque in the background. It will cover everything here, and then you can just adjust the sizes to that. Well, any of these options requires you to add other stuffs into the sheet or into the view, which is less ideal. But here, with the help of Dynamo scripts, what we can do is like see that we are just override the element, assign a very light color and a dash line to not only the families but also the tags. So that way you kind of like, now I really managed to just hide everything, and this goes to every single sheet. Like no matter the shape of your match line, and no matter how many views you have on those sheet, easily just hide everything. If we look at the result in this script, we see that I have managed to select 18 different sheets, and on each sheet there has been a good amount of things that are being override. 40 of them on sheet number 2, and even more on number 3 and 4, and overall there's a huge long list of things that are being hidden, and we all did that in just 3 minutes. So overall that's worth it. And now let's talk about how this is managed, how this is achieved. Because this is really not that hard to understand, so we're going to talk about how it is done. I'm going to walk you through with the different steps in achieving this. So to give you a basic understanding about what are the things to consider and how this is achieved. So the objective is hide things beyond the match line. Well, we're doing that on each views. So the first step you really think about is to find out where's the view, right? So for example, I'm going to here and actually in the view, and this is how it goes. Set this to automatic. And for the first options, we're inside a view. For example, we're inside this view, and we're going to find the match line on this view, and then we're going to get the sketch of that match line. You see that in the background, because this match line is just created as one single entity that is, you see like actually all the match lines behind it. So you realize that, actually I realized that this is the curves. There's like 22 individual lines, and really that's like 1 line, 2 lines, 3 lines, 4 lines, 5 lines, then so on and so forth. So first option is to like try to group them, right? Trying to group them, and then if you group that, you see that there's like couple, that's 14 different groups of lines. And if we join those lines, now you get like only 14 different groups of those. Well, now that we know the match lines, and we just try to group different individuals into a group of lines, we actually only want the lines that are on our target view. So if we go to our view and just get the crop box, we see that there in the background. What we only care is that we have these boundaries, and let's try this a little bit. We care about the boundary and only the match line that are inside this boundary. Well then, this is a good example, but what happens when we, like for example, I might have happened so that I model this match line just like that, and I mean those are good intentions because this is going beyond the boundary of the exterior walls, but in our example, if we showcase like that, we see that these match lines doesn't really touches the boundary of our view crop box. So it create kind of also goes to this one. This line doesn't really touch the boundary of that view crop box. It only touches the boundary of another match line. So there's those kind of problems, and it causes this match line in the background doesn't form a closed loop that helps us to like get things inside this loop or outside that loop for either ways. So here's the other way, the other steps we have to take. We have to take the curves and try to extend them. See if I right now it looks like that. If I feed this in, you notice that this is becoming longer, and if we also extend the end of these curves, notice how there is extending too. So we have to manage to extend the curves so that, for example, if we extend a estimate of 10 feet, that we will just imagine this match line is long enough to touch the boundary of the curve, the view curve, that is. So if we just get to unpreview this, preview this, and then we finally get the ideal curves. We're going to, these curves are, if we really look at that, they are at the ground floor level, but our view curve, because this is a ceiling view, is actually, well, it's actually at Z level 2. But yeah, I know that if we go to like level 2, they are not on the same plane anymore. So on the other hand, we're going to pull the curves onto the plane, onto the current view plane. Now we have these curves. What we really need is only, again, what we really need is only the curves that are inside this boundary of the view crop box. So we're going to check if they intersect by bringing in the view curves. Actually, not just the curves, but also like we create a surface by the view crop box curves. So like that. That is the surface. All we need is the match line that intersect with this surface. Feed this in, and it says whether it intersect. What we only need is the one that actually intersect with. So only 2 of the curves. If we read these examples, it says only 2 curves actually intersect with the surface. That's the one we want. Let's preview this. And we're going to use that, the intersecting curves, to actually we could try to view that by unpreview all of these. See, that's the input curves, and in the background you see that there's the only 2 curves that actually intersect with this target view that we're working on. And we feed that in, and we use the surface to try to get the split of those surfaces. Now, how do we look at this? Each of the lines split the surface into 2. If we look at them one by one, for example, we look at the first one, the first surface of the first group, we'll see something like that. That's the boundary. And then let's look at the, that's the first one actually. So we see that it actually is splitting the surface into groups, and into groups that represent splitted by the surface, by the match line. So we're gonna feed that in, and all we need is we only need the surface that are being split into more than 2. Imagine that. And feed this in using those lines as oh, and then after that we split the surfaces. So how do I explain this? You have the surface on the right, and then the split surface on the left. The one we want is the one on the right, because that's the center of this view. But how do I know that's the center of the view? We use this Polygon containment test, and then we feed in the view center point. See that point in the center? Whichever surface or whichever polygon of the surface parameter curves that contains that surface will be the target point that we want. If we look at this, and then we see that we get this surface which contains the center of the view, and then the other surface which is the other matchline split surface that contains the center of the view. So now I get two of them. The last step is to fit this in, and let's do a intersect O with the original surface that we have. And the resulting surface should be the target one, that is the center of that is the line, the space that's been separated and kept as the final, how should I say, final center piece. So if I highlight that, why is this? You see that face, right? The solid white surface in the back, that is the target place. We can just use this polygon as the source place to track if everything in our view is fall within that place. Now these are all the elements in our view, and we just get the location point. Let me preview that. We have all these points, and the final question is to like whether those points falls into this polygon, and we get what we want. We will filter out these point that falls into the target polygon and get all the things that remains outside the polygon and use those as the information to give it a specific override. Now we are in this view. Let's try another view, and so that just to prove our theory. For example, over here, like that's a good enough view. And if we just go back to run, and refeed in all these points. Oh, we notice that this has become goes to the other side. Yeah, there. In the back, you see that now this is the new new view and new match lines and the new target surface in the background, showing all the element on the view as a dot and showing the polygon or the surface as a solid white surface. So that's how it's done. It's not just splitting a view versus a line. It's actually splitting a surface with a line. Or if you go to the 3D concept, it's splitting a space with a plane represented as a line. Now that we talked briefly about how this is achieved, what we have to consider again still is how do you control it? Because we have just override these elements, and it usually is very worrisome to try to override things on view, because for what we know that design could be changing, the match line could be moving, or the element can be moved around so that they comes back into the project, and some other things could be moved up beyond the match line. Again, as design progresses, that way we need not only the ability to track what is outside the match line, but also to track what has been moved now that they sit inside the match line. So that's why I didn't go straightly to hide these things, because if you want to obtain the things being hidden, that's going to be really hard. But if we're just trying to override them, in here what we can really do is we can track what has been overridden. And if they have been overridden in the past, and now in this new calculation, they kind of falls inside the match line, we should reset that override, because now they are they shouldn't be overridden. They shouldn't be half-toned. Showing in this example, what is that actually I give it a color by RGB and then a specific line type. That is the information we're going to do, and that is how we're going to override them. These are the Revit API access. I create a specific override graphic settings and give it the target color value and give it the target line pattern ID and assign it to every single element in this view that falls beyond the match line. But in the meantime, we're going to get everything that is inside the match line, and we're going to query it for its element override values. We're going to get that color and that line pattern ID, and when these color equals our pre-established color, these line patterns equals our pre-established line pattern ID. That means they used to be beyond the match line, and now they are inside the match line. Once these two categories both meet, we're going to reset that so that they no longer sit beyond, they no longer keep being half-toned or dash lined. So that's the idea about not only setting the element, but also to try to reset them, to keep an eye on what has been done in the past. And if we're keeping the same override consistent as time progresses, we could run this every time there's a new background or there's a new design input to know that if those things are still within the match line. If I run this right now, you see that it will half-tone these lines and then return these into solid, because now they are inside the match line. Imagine if those things are hidden, now you need to find all the hidden element in the view. That is like way more advanced. You need to find them, whether they are hidden because they are hidden by category, by work set, by view range, all the kinds of reasons. It's rather simple if we just check the in-view visibility graphic settings if they equals what has to be in the past. So now you see that we have moved something inside, and move something outside, they still maintains the same logic. So what seems to be a really straightforward script or workflow is actually there are things to consider. You have to think about how to split the existing view by different match lines. Some of them need to be extended so that it touches the boundary, but you don't want to extend all of them to touch. If you extend it by like 20 feet, even these examples, that line will touch the boundary and then you lost half of these elements. And then after that, you're going to consider as time changes what happens when there are things being moved. And we need a script, we need the same method to try to unhide them, to unoverride them. We can't just manually go there and do it ourselves. The script has to do that for us. And this is a complete workflow in this way, which I see that there are good things about it and there are bad things about it. The good things is that you can override the tags as well. If I actually create a say I just don't do this, we just create mask regions, a few regions. We'll create mask regions. We can't hide what's the element beyond the match line, but we won't be covering these tags, and now it just looks like weird. Why do I even have all these tags in there where there's no element? So the good thing about the script is it actually still shows some of these elements and it kind of assign the same graphic override to the tags as well, the annotations. The bad thing is that you still like you need to run this thing. It's not like constant. Whether there's a field region, everything you move is like instantly hidden. But for the script, you kind of run this. It's not like in the background. So there are pros and cons in this workflow, and you have to consider like future changes as time progresses and how to rewind some of these overrides you did in the past. So yeah, here's this workflow. It's not as easy as it seems to be, but it is still a lot easier when you have a lot of scope box, a lot of match lines, and a lot of element. In this workflow is definitely better than changing all these things manually. Okay, that will be all. Thank you. Till next time.